Let's now move on to chemical weathering. This happens when chemical reactions alter or destroy the minerals. Examples would be dissolution. So this is when water is a solvent that slowly dissolves away minerals. Next is hydrolysis. So that's when chemicals actually react, with minerals chemically react with water. Next is oxidation, where minerals chemically react with oxygen. Last is hydration. So that's absorption of water into the crystal structure of minerals, and this can lead to a shrink swell type action. Moving forward. Let's look at dissolution. Now, water molecules are polar. Let me get my pen out here, and so we can draw. Cool. So let's look at a water molecule. We have our oxygen, which is negative ion. So an ion is just a charged atom. Then we have two hydrogens, so our little Mickey Mouse molecule here. Hydrogens are positive ions, so they're cations. Oxygen's a negative ion, so it's an anion. So when you look here at water, it's said to be polar, like a battery. So it's more positively charged on the end where the ears or the hydrogens are, and it's negatively charged here where the oxygen is. So that makes it polar. It has positive charge on one end, negative on the other. So that means that water molecules can actually line up negative to positive, and they are attracted to each other, right? That is called cohesion. When they're attracted to something else, that's called adhesion. But anyway, when you have ions in a solution, they are attracted to these water molecules. So salts are a good example of this. Salt dissolves away in water. So that would be an example of a dissolution reaction. And another example of a dissolution reaction would be limestone, as you see in this image here, dissolving away with interaction with water. Then we have hydrolysis. So that's an actual chemical reaction with water. So for example, we're looking at potassium feldspar mineral in that picture. I know it's potassium feldspar because it's pink. And when it reacts with water over time, it eventually becomes a mineral called kaolinite, which is a clay. And this is often used as a cementing agent in sedimentary rocks. And it's easier to break apart kaolinite, which is this clay type feeling mineral, than it is to break apart this really tough mineral feldspar. So hydrolysis makes feldspar more easily broken apart. Another example would be oxidation of, for instance, an iron-rich rock. So when you expose iron to oxygen, it reacts and it turns red, it rusts. And so you could see with this broken apart iron-rich rock here that the outside has formed this red rind. It has oxidized, where the inside is not in direct contact with the atmosphere or in it, so it has not received the same amount of oxygen that the outside has. So then it's easier to break apart this rusty outer shell than it is to break apart the non-oxidized iron in the center. Lastly, we have hydration. Now, this happens, for example, with shrink swell in clay. So clay absorbs water, and as it absorbs water, it swells. And then when it dries out, it shrinks. And just like our freeze-thaw action with the mechanical weathering that you saw, this shrink-swell action loosens up and breaks apart rock or clay, and it's another form of weathering. So in the next series of slides, we'll talk about how chemical and physical weathering work together and then the later processes that happen.